Good morning, my friends. Welcome back to another episode here in the Off-Kit Garage in... May I present? Yeah, hopefully it stays this way and recharges our battery, because today we are going to start the test with the Gobel Power, the new Gobel Power BMS in this battery here, and the JK-Inverter BMS version 19 with the newest firmware 19.30, which I linked down below. And also the Victron Smart Shunt, which is nicely packed and wrapped here because I don't like these open contacts here on the floor. And with this test, we want to find out which measurement of the state of charge is the more precise. Yeah, Smart Shunt, JK-Inverter BMS, or the new Gobel Power BMS, the P... whatever it says here on the screen. So, as you have seen in the intro, I have replaced the CATL CB530 battery here, our Frankenstein 2 battery, so to speak. I've pulled this one out and used the connection cables coming from the Powerwall here on the left to connect these two batteries only. Yeah, they are in parallel. Positive is coming from here, going up to this battery, and the other positive is going to this top battery. This one is off, this one is off, this one is off now, this one is off. All right. All the batteries are off except this one and this one. This is a 135 ampere hour battery. This is only a 100 ampere hour battery. So 235 ampere hours roughly we will get in parallel with the battery shelf. And these are connected to the Powerwall 2.0. You can watch this experiment live on the internet here. I'll link this down below. It is the SPET Calibration Center VRM from Victron online. We'll have a close look in a second before we turn everything on. And of course, first of all, we need to set the parameters right for these two batteries here. So making sure they are fully charging, they are resetting to 100% correctly. And then with this weather in the background, hopefully we get this all done today. So before we have a look at the settings, I want to show you how I've connected all these batteries now back to the system here. I'm using the CAN cable connection, the CAN port here on this BMS, on the Gobel Power BMS, to go back to the Servo GX, to the CAN port, yeah? The BMS CAN port, as usually. And here on the JK-Inverter BMS, I am using the RS485 port with the standard RS485 to USB adapter, which sometimes comes with the JK-Inverter BMS. And this connects to a USB connection and back to the servo as well. So both of these batteries are showing separately now as separate batteries in the Victron VRM. Of course, you need to install a driver for this one, but this is some content for a later video, which is coming out very, very soon. Amazing stuff. But at the moment, we've got the Gobel Power battery and the JK-Inverter BMS separately in the Victron VRM, so we can see all the details, voltage, amps, state of charge, everything. I have forgotten to plug in the Smart Shunt test to the servo as well. So I need to find another 2 meter VE direct cable. There's always something. Alright, my friends, so I just made my own VE direct cable, and I'm so glad we kept these offcuts the last time we made such a VE direct cable. I just used a piece of 4-wire telephone cable, which fits the 4-wire solution of the VE direct cable perfectly. So now we've got a 3.213 meter VE direct cable. The only one in the world, probably. Alright, so now we've got everything cabled. Gobel Power, the new Gobel Power BMS with CAN back to the servo. The JK-Inverter BMS connected to RS485 back to the servo, and the Smart Shunt test with the VE direct cable back to the servo. So in theory, everything should show up in the servo now, right? Alright, let's see what's going on the servo. Alright, we have the Gobel Power BMS here as one of the devices. We have the JK-Inverter BMS as one of the devices. And we can see the Smart Shunt test with our self-made VE direct cable. It is so easy. Because it's not using twisted pair, it's just a straight cable 1-to-1, and it just works. Up to 10 meters, no problem. We also have the Smart Solar Charge Controller, which is not of interest. There's nothing connected, and the GX device relays. Anyway, we want to focus on these three only here. So from a hardware perspective, everything shows up correctly. That's fine. Gobel Power BMS. I am logged in via the RS232 cable, and the battery is still fully charged from our last test when we fully charged it. But I just want to check the parameter settings again. We go to read. All right, so overcurrent warning, which is our CCL, doesn't matter. It doesn't matter. Important is 55.2 volts, maximum charge voltage. Then we wait until the current goes under 1 amp, and this resets your BMS to 100% then. Perfect. 135 ampere hours, full capacity, 150. God, jeez. What's going on here with this BMS? So 135. Right. None of the other settings matters actually. So that is all good. We've got a hard protection value of 100 amps in and out of the Gobel Power battery. All right, cool. Okay, let's have a quick look here in the JK-Inverter BMS. Let's check the firmware. Yeah, it is on 19.31, which I will link down below, as well as the newest computer software on version 6.10 or 3.10, whatever it is. It is all linked down below. All right, let's have a look here in the settings. What is going on? 3.45 volts is the balance start voltage. Perfect. We are charging to a 3.45, and the reset occurs at 3.445 times 16. If we wait for 0.2 hours, 12 minutes. So the Gobel Power BMS will reset to 100% at 55.2 volts if the current is under the threshold. And the JK BMS will reset to 100% if the voltage is over 55.12 volts for half an hour, and then the battery voltage still needs to be over or equal these 55.12 volts. Yeah, this is all set with the state of charge 100% voltage. I made a detailed video recently, I'll link this down below as well, how this mechanic here in the JK BMS works. All right, Gobel Power is set up, JK is set up as good as we can. Let's check the currents here. We've got a 55 amp continued charge current limit. This is a 100 ampere hour battery there. Yeah, probably leave this on 55 amps. I'm not expecting these high currents anyway. Continued discharge current 75 amps, which is fine. And here we've got like 100 amps and 100 amps as hard limits for the protection. So that's all good. How do the voltages? Oh, the voltages we can actually see. Hang on, let's go back to the Victron via M. Yeah, Gobel Power BMS here, 53.7 volts. So this one is 100% charged, and it has now tapered off to the normal rest voltage, yeah, 53.67 volts. JK-Inverter BMS 52.6. I'm not sure, this is probably not correct here because I've used this one for testing as well and mucked around with the BMS settings and everything, so this is not correct. It might be correct, I don't know. And the Smart Shunt test shows 52.8. So the big question is, what is the rest of the system, the battery shelf, look like? We can see this down here, we are on 52.8. So that's actually perfect. That fits right in between all the other voltage measurement. The Powerwall is turned off. As you have seen, we have turned off all the batteries, and these two test batteries, they are not turned on yet. Yeah, I think we are good to go. So I would say we start with the Gobel Power battery and turn this one on. This is the highest, 53.7. And this should then discharge into the battery shelf. All right, you watch the screen here and I'll turn on the battery. Can't see shit. And let's turn it on. Bam. And we can see nothing. There's no current. Ah, here we go. 14 amps only. 14 amps only. Pfft. This is 1 volt difference from this battery to the battery shelf, and it discharges only with 13 amps. Now you can see it over here. All right, next one, JK-Inverter BMS. So we are not sure what this one looks like. 0 amps. So let's turn it on and see what's going on. 30 amps it takes, 28, 26, 25. It tapers off very quickly. All right, that was not too bad. And we should see, yeah, we should see the overall sum here in the Smart Shunt test. Yeah, you can see here the Gobel Power BMS discharges with 15 amps, the JK-Inverter BMS charges with 13 amps, and only the difference of that comes from the battery shelf at the moment. Yeah, as soon as the sun is coming back, yeah, there are some clouds coming, of course, when I do battery testing. Yeah, once the sun is coming back, which is right now, maybe, we should see current coming into both batteries and charging them. While the Gobel Power battery may discharge, it is fully charged, while all the other batteries are not. So we will see a negative current here for quite a while until all the batteries are balancing out now. So that is quite cool. All right, settings. Let's have a look what's going on. Batteries. Yeah, here we can see them again. Gobel Power is discharging, JK is charging, Smart Shunt says we are charging as well, 2.4 coming in now from the solar. And this all basically goes into the JK BMS at the moment, so which is fine. Battery monitor. There's no monitor set, but I want to set the Smart Shunt test as the battery monitor, yeah? This is our point of truth. Yeah, let's have a look in the Victron VM how this looks like. Here we are, and we should see, yep, here we go. Here's our Smart Shunt test. Yeah, we can measure the overall current going into these two batteries. And we can see down here the Gobel Power BMS discharging still slightly and the JK-Inverter BMS battery still charging slightly. This is your point of truth. And then you've got the two competitors down here and you can see how they compare to the Victron Smart Shunt here. Perfect. And I said I linked this address down below so you can watch this experiment live. And also go into the advanced tab here and see all the graphs and everything. All the data is there. Knock yourself out. So at the moment we've got the Smart Shunt Powerwall here connected as well. And this one measures the same as the Smart Shunt test at the moment, yeah, because all the other batteries are off. And the current going through this Smart Shunt is the same, which goes through this Smart Shunt and then into the two batteries. Once they are fully charged, of course, I want to turn on some of the other batteries as well. I don't want to waste this energy and I don't want solar to taper off. So that's why I've installed an additional Smart Shunt just for these two batteries. And these two batteries and this Smart Shunt is what is showing in the VRM. We are not watching this one. So, and of course my data here in Home Assistant is not correct anymore because it still shows 180 kilowatt hours of connected battery capacity, which is not true anymore. And the only thing we need to do is, you can see down here, we still got 180 kilowatt hours of battery connected to the Smart Shunt, to the Powerwall, which is not correct anymore because all the batteries are turned off. So we need to go into the Smart Shunt Powerwall and change the capacity which is connected to that. What is it? 135 plus 100, 235, thank you. And we now have battery capacity of 235 and this should reflect, oh, this is only 12 kilowatt hour additional energy connected to the Powerwall. All right, tiny batteries these are, wow. Yeah, this shows as 9 kilowatt hours available from the Powerwall now. 31 amps going into the battery shelf and 4.3 only in these two batteries. So almost all of the energy coming from the solar is going into the battery shelf at the moment. We fully charge this now and then the other two batteries are catching up. Now the other way around. The battery shelf needs to catch up to these two batteries, of course. So that's why we see the current here is higher than what is going into these two batteries. So it may take a while depending on the weather situation there. Yeah, now we can see it, 8 kilowatt coming in and 112 amps going to the battery shelf and only 22 into these two batteries. So they are definitely on a higher state of charge than the battery shelf. Not taking much power at the moment, but that's good. Majority of the power goes into the battery shelf, charging it up quickly. And hopefully we get to 100% with all the connected batteries today. Well, if not, tomorrow.
1 million, zillion, jillion, dillion, cotillion times later.
Well guys, it has been a couple of days now since we connected these two batteries and the Smart Shunt test here to the system, let it charge. And it is still not fully charged. That was 2-3 days ago now since we connected this, and you can see even my beard has grown longer. That's how long it takes to recharge these two batteries. Well, the weather was not in our favor, I must say. Even we have this nice blue sky in the morning here. Then at 10, 11 o'clock, before the sun comes around the trees onto my solar panels, thick clouds are coming in, and I also had to recharge both EVs. So there was no spare energy going into these batteries. So last night I thought about changing the tactic a little bit here. So what I did, I turned off both of these batteries with the circuit breaker, so they stopped discharging, because this morning I want to turn off the whole battery shelf here and only use the solar energy coming in for these two batteries. So the main objective here is to fully recharge these two batteries at the top, reset them to 100%, and also reset the Smart Shunt test to 100%. So all three are on the same level then, and then we can reintroduce the battery shelf again. And then I'm not worried about it anymore because they can just cycle together with the battery shelf for the next few weeks, and we will see how the state of charge actually compares. All right, so let's see. We've got 0 amps. If I turn this one on, it should get a bit of a discharge. You can't see shit. Discharge current here, maybe not. 0 amps. Okay, let's try this one. See what happens here. -1 amp. Almost nothing, so 0 amps might be correct. All right, these two are back online, and we are now turning off the top shelf, middle shelf, bottom shelf of the battery. Everything stays running, and everything is running from these two batteries now. And now we should see a bit of current here coming in, 3.26 amps. And here we have 6.6 amps. Okay, battery shelf is dead. These two are alive. That's all that matters. So hopefully we got enough solar power today to fully charge these batteries, reset everything, and then we can finally start the test actually. All right, so what I have to do now is I have to limit the current a little bit into the system because we have only these two small batteries now on a 11-15 kilowatt system, and the current could exceed far more than these two batteries are capable of taking. So what we are going to do is going into the settings of the Victron system, going into the DVCC, charge control, and turn off limit charge current, yeah? And set this one to, I would say 100 amps. That would be 50 amps per battery. That is 0.5 C for each of the batteries roughly, if they are charging the same way. Yeah, 100 amps would be the limit for this installation now for these small batteries. And at the moment we are actually discharging the battery, so because there's only 1.5 kilowatt coming in, and I'm actually expecting more clouds to come in today. So these 39% here the battery shows in the Victron system are obviously not correct anymore, because this is the aggregated state of charge calculation of both Smart Shunts. And the battery shelf is off, and we have only two batteries connected on the other side, which is only 12 kilowatt hours or 235 ampere hours, yeah? And this claims it is to be at 45%. Could be true, I'm not sure. I think the batteries are rather at 60-70% actually, but that's why we need to reset everything to 100%. Okay, 0 watts going into the battery shelf, 0 amps, obviously everything is turned off, and all the power, all the 95 watts are going into these two batteries now. That is ridiculous. All right, my friends. Okay, leave this running here for 1-2 hours or so, and hopefully the sun stays and we get some good power into these two batteries and can fully charge them at around noontime. And then we go from there. All right, have a good morning. See you then. All right, we can now see we are getting 6.5 kilowatt from the solar system, and we are charging the batteries now with 4.1 kilowatts, yeah, 76 amps into these batteries. And this is pretty much the maximum it will charge, even we have set it to 100 amps. But it also reduces the charging current here for the batteries because of the DC load we have, yeah. I still got another inverter running. I've still got all this stuff here running on DC basically. So this obviously makes out at 25 amps at the moment, and the sum will be the 100 amps we have set up. So 75 is maximum, but that is fine, because when we have a look at the SPED calibration center VRM, yeah, we can see here the 75 amps coming into the Smart Shunt test, which is our point of truth. And we are charging the Zeppelos battery with 135 ampere hours with 40 amps already, yeah? And almost the same goes into the 100 ampere hour battery, the JK battery, exactly, with the JK-Inverter BMS. So 40 amps in here 135 ampere hours, and 36, 37 amps into here 100 ampere hours. This is probably the maximum I want to charge as well. But if we go back to here, we can also see that the frequency has already increased to 50.9 Hertz. So it is now limiting the solar which is coming in, especially the AC stuff. Now another load has kicked in. We can see that here, 2.7 kilowatts. And we can also see the sky has finally cleared up, so there are no clouds anymore. We have got pure sunshine here where the sun comes around. Finally, best weather for battery testing. Yeah, you can see here again 50.9 when the load is gone, so it's increasing frequency, reducing the solar coming in. So what I'm going to do now, so let's have a quick look. Okay, let's have a look at the Gobel Power BMS, and we are charging with 45.45 amps now. Yeah, there's no balancing happening at the moment. We've got a deviation of 13 millivolt, but we are still in the flat part of the charge curve, so there's no need for any balancer or something. Having a look at the JK BMS on the other side, it is connected to the 100 ampere hour battery. It claims 97% state of charge. Okay, hasn't been calibrated for a while apparently. Cell difference here is about 17, 15 millivolt as well, so very comparable, but again flat part of the charge curve, so there's nothing to worry about. But we are at 54.4 volts, but we are pushing hard 40 amps into these batteries. Yeah, need to pay attention to the temperatures as well. Here in the Gobel Power battery, 30 degrees on the cells, and here we've got 28 at the cells as well, so this is all good. All right, I think we are getting fairly close now, so we should be able to fully charge these batteries today and reset everything to 100%. When it gets more interesting, when the voltage rises to close to 55 volts, I'm back here and we have a look at the balancing, the active balancing of the Gobel Power BMS under real-world conditions, as well as the balancer here in the JK. Let me have a look. This is a 200 amp version 19 BMS, yes. So we will have a 2 amp active balancer. It should have no trouble to balance these 100 ampere hour cells here and make this a perfect, beautiful top balance. All right, give it another half an hour, hour or so, and then I'll be back here with some more interesting stuff. I just missed it. Down here you can see the Smart Shunt has just reset to 100% state of charge. We are still charging the Gobel Power battery, the Gobel Power BMS, with 8 amps. It sits on 94% state of charge, and the JK-Inverter BMS has just reset to 100%. The charging status has changed to absorption, and the timer is running for 31 seconds. Balancer has kicked in. We've got a deviation of 30 millivolt, and here we've got a deviation of 26 millivolt, which is under 50 millivolt, so the balancer doesn't start. Yeah, it needs a trigger differential voltage of across all your cells of 50 millivolt. If the current is still above 2 amps, it is now just under 2 amps, so now it needs 30 millivolt of deviation, otherwise the balancer will not even start. Well, here in the JK-Inverter BMS, the balancer is nicely running. We are 27 millivolt deviation, and here we have just reset to 100% as well. I've missed it because I was looking at the JK-Inverter BMS. So both BMS have now reset to 100% state of charge, 55.2 volts around. Current is almost at 0 in both BMSs. The balancer has now kicked in, thank you. And the Smart Shunt has reset to 100% as well. This is exactly what I wanted to achieve now, because now we can let these two here cycle on a daily base up and down and see how good the state of charge measurement and calculation estimation is of the Gobel Power BMS in comparison to the JK-Inverter BMS, in comparison to the Victron Smart Shunt. I'm not sure why this BMS has actually counted 16 cycles already. This is definitely not true. All right, I would say give it another 5-10 minutes and then we should be ready to connect the other batteries again, and this will be the end of this video then. I mean, almost. Okay, so we are now balancing for a while. The Gobel BMS does not balance any further. We are far under the trigger threshold to activate the balancer, while the JK BMS is still balancing. We are down to 5, I've seen 3 millivolt deviation. So 20 millivolt is still good, but here it is better. Alright my friends, I think I will lower now my charge voltage to 53.6 volts, wait until the batteries are coming down in voltage, and then I can turn on all the other batteries again, because they are on a lower voltage obviously, and I don't want to have a 55 volt battery in parallel with a 52 volt battery. But here we are still 10... Oh, look at this, we just had a cell over voltage alarm, 3.5 volts. Yeah, there was a bit of an orange mark here. And I wonder why the balancer is not coming on, right? Okay, let's go into the Victron Connect app, go into the car port, which is my master MPPT solar charge controller. And we go into the settings, battery, expert mode, and we say absorption time is now over. We set this to 1 hour, click on OK, and now they should all 4, yeah, this one flicked to float already, and the others should do this as well. There should be 4 green lights, perfect. The light destroyed it, 4 green lights, so they're all listening to the carport MPPT. So you don't have to go into each of the MPPTs to change settings. You change it on one and it synchronizes across your network. Perfect. This is using the Bluetooth Victron Smart Network. I'll make a video about this. I'll link this down below as well if you're interested how this works. But the Gobel battery and the JK battery as well as the Smart Shunt are on 100% state of charge. We check here again. We just wait for the batteries to come down in voltage a bit. So let's turn on some loads again. Pull pump, I turned everything off because with the clouds I could not fully charge these batteries here. I had to turn off some loads. Yeah, and here you can see everything is on 100% now, even the Smart Shunt in the battery shelf, because the voltage was over 55.12 volts for half an hour or something, whatever it said, and it reset to 100% as well. So everything is a bit out of sync. I need to recharge all the batteries to 100% now to make this all work, but that's fine. We are discharging the batteries now and holding 53.6 volts. And once they have come down a little bit, yeah, I think it's okay now. Turn on one of the batteries and see what the current does. Gobel discharging with -20 and here the JK -16. I'll turn on another battery. There you go. Middle shelf battery is turned on, -20, -16, and I'll turn on the bottom battery as well. Alright, battery shelf is back in action. And you can see the discharge current of the Gobel Power and JK battery were not that high as expected because the voltage was already down to 53.6. And we can see here in the battery shelf we've got 52.8 now. What it measures at the DC bus, it's not far away from the 53.6. So I would say everything less than 1.5 to 1 volts is safe to parallel. The Gobel Power sits on 99, the JK sits on 99. And the SPED Calibration Center sits on 99.7 so far. Yeah, that will be very interesting to watch. I'll link this down below again here, SPED Calibration Center in the Victron VIM. You can see the Smart Shunt on this side. You can see the Gobel Power BMS on this side and the JK-Inverter BMS on this side. They should be all charging fairly equal. So let's see what happens over the next 2 or 3 weeks. Alright my friends, so far this video from today, recharging these 2 batteries to 100%, reset everything to 100%, and now we can start with the actual test, comparing these 3 measuring and state of charge calculation methods together, and see if the Gobel Power BMS is actually better in estimating, measuring and calculating the state of charge. Thank you very much for your support. Thanks for all these amazing and beautiful people who are donating to the channel or becoming a channel member for less than the price for a coffee a month. Thank you very, very much for that. More videos are coming soon. Leave a nice comment under the video. If you are new here, subscribe. Hit the like button if you like this sort of content. And until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. Wait, before you go. It is now the next morning. So yesterday we have reset these Smart Shunt and the 2 BMS to 100%. Everything was fully charged. Then I've discharged the battery a bit overnight. And this morning we are at 44.6%. The Victron Smart Shunt tells us. The Gobel Power BMS sits on 46%. So very close together. 44.7, 46. There's 1.3% only. JK-Inverter BMS though, 37%. This is as far as you are away from the off-grid garage. But we have to be careful here with the judgment now, because the battery is not fully charged at the moment. So it can be that the Gobel battery and the JK battery are discharging in a different way. Yeah, they are in parallel, but for some reason maybe the JK-Inverter BMS has discharged a bit faster than the Gobel battery. So that's why we see the JK-Inverter BMS here on 37% state of charge. Yeah. So before they reset again, this is the moment of truth when we have to watch the Smart Shunt, which should be then close to 100%, the Gobel BMS close to 100%, and the JK BMS very close to 100% as well. But from what I can see here, it will be very interesting to watch. The link is down below.